Okay, so this was a total impedance problem. Several elements here. We have, from labeling nodes, I'll put them in orange. Here's a node up top. Here's a node at the bottom, and here's one node in between the resistor and the inductor. The first thing I said to do is make sure everything is in impedance. Well, you don't have to change those, they're already in ohms, but I do need to do something with the 0.02 microfarads and the 80 millihenries, right? I need to put those as Z's. Z of a capacitor is a matter of negative J X sub C, right? So the X of C is 1 over 2 pi FC, or 1 over omega C. But we have F, so we'll use 2 pi F. F is 2 kilo, C is 0.02 micro. Oh, I have messy there. 0.02 microfarads. Whenever I plug that in, I'll see if I get 2 times pi times 2000 times 0.02 e negative 6, and I get 3978.9 ohms. So if I was relabeling this, I would write negative J 3.979 kilo ohms would be in engineering units. The Z of the inductor over here, right? ZL is positive J X of L, or X sub L. X sub L is 2 pi FL. 2 pi, 2 kilohertz, L 80 E negative 3 is what that is, how I would type that into my calculator. 2 pi times 2000 times 80 E negative 3. And I get 1005.3 ohms. So over here, I'd write J 1.005 kilo ohms. So now my Z total, and I'll write it with just the labels first, but as I have R1 is paralleled with R2 plus L, actually I'll say ZL plus ZL paralleled with Z of the capacitor, because that is what is in between those nodes. So they're all paralleled except those two in series. So if I was writing this on the calculator, I'd write 1 over 2000 plus 1 over 200 plus 1005 J plus 1 over negative J 3979. I'm going to type it in the calculator, make sure that's the correct numbers. 200 plus 1005 J plus 1 over negative J 3979. Yeah, so on mine, must have had a rounding thing, but it's close enough. Not close enough, that's not quite right. Did I type that all in right? Oh yeah, nope, I missed a 0. So if you wrote this down and you got the wrong answer, you might lose a point because that's just a calculator error. There we go. I had originally written 20. So with my rounding, what I got was 708.2 plus 723.97J. So if I was looking at my Z total, right, this would be my R total, and this would be my X total. Actually, and say this 723. So if I was asked for my total circuit, right, my total resistance is 708 and my total reactance is 723. It's overall an inductive circuit, but in the polar form, I got 112.8 angle 45.6 degrees. And that's